Hi all, and welcome to a YouTube lecture on solving equations using factoring. So the first thing we want to do is talk about our objectives. We're hoping to be able to define a quadratic equation and write it in standard form. And we're also hoping to understand the zero product rule so that we can utilize it with factoring to solve equations. So that's what we're going for. What is a quadratic equation? How do I write it in standard form? How can I use the zero product rule in factoring to solve those equations? Let's start with our definition of a quadratic equation. So first of all, a quadratic equation has this exponent. We want an exponent higher than 1, so we don't want a linear equation. So this would be an example of a linear equation where the power on the exponent is 1. For our quadratic equations, we want an exponent higher than that. We want a 2. We also want to make sure that A, B, and C represent real numbers, which means that we would normally have numbers sitting there, like 4x squared minus 2x plus 0 equals 0. So it's fine for one of our constants to be 0. We just want to make sure that we have real numbers there, and real numbers include 0. What we want to make sure that we want to avoid is this A does not equal 0. If A equals 0, then the only thing left would be bx plus c, and we'd be back to a linear equation. So we cannot allow A to be 0. But that rule doesn't apply to B or C. B and C can still be 0. Alright, now let's talk about the zero factor property. The zero factor property says if I multiply two numbers and the product is 0, then one of those two numbers was 0, or they could have both been 0. Let's look at some examples with numbers. If I multiply 3 times x and get 0, then the only possible solution for x would be 0, because the only way I can turn 3 into a 0 is to multiply it by 0. The same thing if x is in front, then x times 4, that means x had to have been 0, because the only way to make 4 0 is to multiply it by 0. And that is what our zero factor rule property is saying. It's saying that if I multiply two numbers and I get 0, then either this one is 0, or this one is 0, or they're possibly both 0. And we can see that when we write this in standard form, we set it equal to 0, which is why we need the zero factor property. So if I just factor this polynomial, I'll get two things that multiply to give me 0, which means that, since I'm factoring a quadratic, I'll get two linear equations, and I know how to solve a linear equation. So the zero factor rule allows us to exploit factoring to make linear equations that I can solve to solve the higher quadratic equation. We're going to do this by using the following method on this video. I want to be sure that you can use any method. I don't care how you do the problems on the exams, as long as I can understand what you were doing. So as long as you've written out your steps in a clear enough manner that I can follow what you're doing logically. If you know some other awesome method, then use that. And if you really think it's great, then send it to me, and maybe I can make a video utilizing that method. For our method today, we're going to write the equation in standard form. We're going to factor it completely, so we're not going to accidentally leave any powers of 2 in there. We're going to set each factor equal to 0, and then we're going to solve, so this will create at least 2 equations. And we're going to solve those 2 equations after they're set equal to 0. And then our last step would be go back and take the solutions from this and check them back in the original equation. Unfortunately, in this video, we won't really have time to work through the check part of it, but I'm hoping to make later a video where we go through the check process for a quadratic equation. Okay, so on this slide, we have x squared minus 25. And if we think about that standard form of the equation, we know there's usually a bx term. So let's write that standard form. It's ax squared plus bx plus c equals 0. And we don't have a bx. Remember, there's no rule that says b or c can't be 0. So in this case, we just have a bx where b is 0, and so the x term isn't written. That means that we can just solve this. It's written in as standard as we can get it. So the next step would be to factor completely. If I remember from factoring, this is the difference of squares. I've got x squared minus 5 squared equals 0. So using the difference of squares, this gives me x minus 5, x plus 5 is equal to 0. And now I'm going to use the zero factor property. So if we go back a slide, I factored completely, I've written it standard form, and I'm going to set each factor equal to 0. So moving forward, we set x minus 5, this first factor, equal to 0, and x plus 5, this second factor, equal to 0. And we're writing the OR because the zero product rule told us that this is equal to 0, or this is equal to 0, or possibly they're both equal to 0. Now we're going to solve these linear equations. So I add 5 to both sides for this equation, and I subtract 5 from both sides on this equation, which gives me x is equal to 5, or x is equal to negative 5. And I'm going to circle or box both of my solutions. Moving on to the next problem, we have 6x squared equals 12x. Standard form is a x squared plus bx plus c is equal to 0. And that means I need this moved to the other side so I can have it equal to 0. So the first thing I'm going to do is subtract 12x from both sides. These two will become 0, and these two are not common terms, so they cannot be added or subtracted within each other because they're not like terms. This one has a power of 2 and this one has a power of 1. That secret hidden 1 that's there. So I will write 6x squared minus 12x is equal to 0 because again these are not like terms, so they can't be combined. Now that I have it written like this, it looks like the only thing I'm missing is the c, the plus c term, but again there's no rule. It says c can't be 0, so in this case c is 0. We don't need to write it, but we do need to factor now. It looks like I have a 6, and 12 is really 2 times 6. I have a 6 here, and I have at least one x in each one, so that's what I'll factor out, a 6 and an x. So a 6 and an x. Taking the 6 and an x out of the first term, I have just x left over, so if I multiply that back in, I would get 6x squared minus, and then if I factor a 6 out of 12, I'll have 2 left, and if I factor an x out, I won't have any x's left, equals 0, and I can check if I put this 6x back in, I would get 12x. So checking my exponents, I've got 2 exponents, they're both 1, so it looks like I've factored completely, so it's time to separate using the zero factor property. 6x is equal to 0, or x minus 2 is equal to 0. Here I'll divide by 6 on both sides, and 0 over 6 will give me x is equal to 0, or add 2 to both sides, and I will get x equals 2. So my solutions would be x equals 2 and x equals 0. We have this new problem here, which has our middle term on the right-hand side. We don't want that. We want 0 on the right-hand side. So we'll fix it by adding 3x to both sides. 3x doesn't have anything in common with these two, so there's no like terms to combine, so that gives me 2x squared minus 2 plus 3x is equal to 0. Technically, to be in standard form, we need to write it in descending order for the powers, so we'd start at 2, the next term should have x to the first, and the next term should have x to the 0. So let's reorganize. 2x squared plus 3x minus 2, and now it looks like it's in standard form, which will make it easier to factor. I've got 3 terms and a leading coefficient. which means that I need to use that superstar method, or whatever method you know, for factoring these. I'm going to start with my superstar method. I'll use a different color since this is scratch work. I've got big X. I draw my little division bar through the middle. I need in the top of the X 2 times negative 2, which is negative 4. And I need in the bottom of the X the middle term, which is positive 3. The bottom of each one of these fraction bars will get the leading coefficient of 2. And in the top of each of these fraction bars up here, I'm going to write the numbers that multiply to give me negative 4, that add to give me a positive 3. So let's see, positive 4 minus 1. So 4 times minus 1 gives me a minus 4, and 4 minus 1 gives me a positive 3. The next and last step would be to make sure that there's nothing in these two fractions that I've created, right here and right here, that will reduce. So checking the first fraction, 4 over 2, that reduces to 2 over 1. 2 over 1. So I remove a 2 from each one. And then negative 1/2 can't reduce anymore. So I've got the coefficient of x in the denominator and the constant term in the numerator. Rewriting over here, that gives me, open parentheses, the coefficient for x is 1, so just x, and then the constant term is a positive 2, times the coefficient of x is 2, and the constant term is negative 1, is equal to 0. And if I'm not sure I did that right, I can always multiply it back together and make sure that I get back to the original equation. So now I set x plus 2 equal to 0, or 2x minus 1 equals 0. So x is equal to negative 2, or x is equal to 1/2 by adding 1 to both sides and dividing by 2. So I'll circle my two solutions, and we'll move on to the next example. And this would be our most complicated example. It's the furthest from standard form. Standard form has an x squared in it, and nowhere in this equation do I have an x squared, so I need to start simplifying so that I can see whether or not this is even a quadratic formula. Do I need quadratic methods, or do I need linear methods to be able to solve this? So first thing I'll do is distribute this x. So I get 9x squared minus 12x from distributing this x to both terms. And that is equal to, 12x from distributing the x to both terms, there we go, minus 4. And then, it looks like I've got a quadratic formula, or a quadratic equation, so I'll go ahead and write it in standard form by moving 4 to the left by adding 4 to both sides. 9x squared minus 12x plus 4 is equal to 0. Now that it's written in standard form, and I've written the powers in descending form, it'll be easier for me to gather what I need to factor. So it looks like I've got 3 terms and a leading coefficient. I've checked for a GCF. 9, 12, and 4 have no common factor among them, so there's no way to simplify this and get rid of the leading coefficient, which means I just need to start my super x method. So big X, a fraction bar through the middle. I'm looking for 2 numbers that will multiply to give me 36 and add to give me negative 12. I need to write the leading coefficient in the denominator of these 2 fractions I'll create, and now I need to think of my 2 numbers. What 2 numbers will multiply to give me a positive 36 and add to give me a negative 12. So 36 is 6 times 6, and negative 6 plus negative 6 would give me negative 12. So if I make this a negative 6 and I make this a negative 6, then these 2 numbers would multiply to give me a positive 36 and add to give me a negative 12. And now I just got to reduce these fractions. So it looks like they're the same fraction on both sides. They have a 3 in the numerator and the denominator. So I'll factor that out, and that will leave me with a 2 in the numerator and another 3 in the denominator. 2 in the numerator and another 3 in the denominator. The denominator is going to give us the coefficient of x, and the numerator is going to give us the constant. so it's actually negative 2. Don't forget that negative. I have 3x minus 2 times 3x minus 2 equals 0. Now that I'm done doing that, I see that I've got the same exact binomial multiplied twice, which means that this was a perfect square trinomial. And I can double check that as this is a perfect square, 9, and this is a perfect square, 4, and the middle term is 2 times each number. So 2 times the square root of 9 times the square root of 4. 2 times 3 times 4. So if I had recognized that, I could have gone straight to the solution, but I didn't, so I used my superstar method. I've got 3x minus 2 equals 0, or 3x minus 2 equals 0. It's a bit redundant to solve them both, so we'll just solve one. Add 2 to both sides, and I've got 3x is equal to 2, divide by 3, and I've got x is equal to 2/3. So, do I have one solution or do I have two solutions? And the answer to that question is you should always have as many solutions as you did powers. So, the power on the variable is 2, I should have 2 solutions, and I do. I have this solution twice, so we can say with a multiplicity of 2. So, this solution twice. Okay, that's our last example and the end of this video. Thank you for watching, and I hope it helps you with your homework and practicing for the exam.